Hello, geometry students. Welcome back to another video lesson today with Mr. G. We're going to continue working with our quadrilaterals, but today we're going to get to everybody's most favorite part of geometry, the proofs. How can we use the definitions, theorems, properties, all of that stuff to kind of prove which quadrilateral we have or the properties of a specific quadrilateral? So as we get started, I want to give you a couple of hints because I think we're struggling to miss a couple of key concepts, especially on the last test. In this section particularly, we want to know, what are we trying to prove? Are we trying to prove it's a parallelogram? Are we trying to prove it's a trapezoid? Are we trying to prove that it's a square? Like, what are we trying to prove? Because that key piece will tell us what definition we're trying to fulfill, right? Again, if it's a square, I need to show somehow that there's all 90-degree angles and that each side is congruent to every other side. So the definition and knowing what we're trying to prove will help us. Second, what clues are they giving us? Parallel lines. If they tell us something about parallel lines, we should be thinking alternate interior angles or corresponding angles, right? Showing that those are congruent to each other, or vice versa. If I can show alternate interior are congruent. Do they give us an isosceles triangle somehow, which helps me to show the angles or the sides are congruent using it-bat and sit-bat, right? So using some of those clues as to what they give us. Along those same lines, one of the clues to look for is the transitive property. Can we tie some common pieces together using that transitive property? Angle A is congruent to angle B, but B is also congruent to C. So we know then that A and C have to be congruent, tying it together, those common pieces. And then last but not least, we're going to have to go back to what we've done all year long. What definitions and theorems did we learn in the past that'll help us? Definition of midpoints, definitions of circles, vertical angle theorem, things of that nature that will help us decipher some of the pictures. So I got 3 examples for us to go through. These are probably pretty important examples for you to write down and go through as we're going through them together. Answer the questions as they pop up. All right, so this one's partially filled in. We need to complete the proof using the figure over here at the right and this information. AC is parallel to ED, and BD is parallel to AE, and BD is congruent to CD. We are trying to prove that ACDE is an isosceles trapezoid. So here's what we're trying to prove, that it's an isosceles trapezoid. Therefore, what do we need to prove and go through the steps to show on this quadrilateral? 2 pieces. Remember, we need to show base angles are congruent, and one set of parallel sides. So we have to have both of those be true in order for that shape to be called an isosceles trapezoid. Well, notice they've already given us one of them. AC, this long line down here, and I'm just going to draw it underneath so we can see it, is parallel to ED. So the top and the bottom, if this is a trapezoid, are already parallel. So we've met this criteria. We need to somehow prove that A and C are congruent, or that E and this angle up here by D are congruent, which is this process. So the first thing they write down is that BD is parallel to AE. They use the middle one, parallel, given. That parallel should tell you something right away. If they're parallel, I am looking for alternate interior angles, or I am looking for corresponding angles. That's what I'm looking for. Anytime I see parallel, I'm looking for one of those 2. So I'm going to look D to B to C. This angle congruent to angle A. A congruent to this angle. How do I know that's true? Again, they've told me that BD is parallel to AE. So if I bring that out, right, here's AE, here's BD, and they're parallel, meaning this is the transversal that connects them. Here's A, here's B. What do we call those two? Those are corresponding because they're in the same spot. They're on the same side as the transversal. They're both below the parallel lines. They're in the same spot, so corresponding angles. All right, so that's what we would fill in here, corresponding angles. Now letter C, BD congruent to CD. Well, they already told us that, right? What's the reason? It's part of the given again. And sometimes that'll happen in our proofs where we're explicitly laying things out step by step, where the given might happen more than once. So again, if I look at triangle, and I'm going to try and pull the triangle out now, DBC, D to B to C, and they're telling me this side is congruent to that side, that should send off an alarm. I've got an isosceles triangle, which means D to C to B, look at that one, D to C to B is congruent to D to B to C. DCB is congruent to DBC. If you don't remember that that's it-bat, you can always draw the diagram. What did we start with? We started with the sides, which then gives us the angles. So if you don't remember the name, just draw this picture. Perfectly acceptable. Okay, so now in this diagram, I know that B is the same as C. But wait a minute. We said that this B was the same as A, and this B is the same as C. So they have something in common. And when they have something in common, I can tie them together. I can say D to C to B, which is this part, is the same as A because they have something in common. And when they have that piece in common, I can now say because of the transitive property. They have that angle DBC in common. Have we then showed that the base angles are congruent? That angle A down here is congruent to angle C? Absolutely. Therefore, how do we know it's an isosceles trapezoid? The definition of isosceles trapezoid. It's all because of this definition of an isosceles trapezoid. So a lot of steps to go through there to prove that all of that gave us two base angles. Let's take a look at another one. All right. Given angle XJA is congruent to angle JKC and angle XJS is congruent to angle JAC, we need to prove that JACK is a parallelogram. How do we prove something's a parallelogram? Two sets of parallel sides. So I need to show somehow that both sides are parallel. First thing they give me, XJA is congruent. So XJA is congruent to JKC. Boom. I know this angle is congruent to this angle. That's given. And then I'm going to do this other one in red. XJS? There is no S. To JAC. I'm guessing that was meant to be XJA. XJA, so that's also congruent to that one. So let's just focus on the blue ones, okay? The two blue ones are congruent, okay? So I'm going to draw it. Let me go grab the blue. We're going to draw it like this. Here's one of those, and the other one. Here's this transversal, showing me that this is congruent to this. What do we call those two? Those are corresponding. So that's my reason, corresponding. And if they are corresponding, what does that mean about the lines? That JA is parallel to KC. All right, corresponding angles. Again, parallelogram. If we're trying to come up with two parallel sides, we're going to use corresponding or alternate interior. Now, if I take the red one, notice in this red one, what we have is we have this line up here, and we have this line over here being cut by this JA, where this angle is congruent to this angle. What do we call those two angles when they're on opposite sides? Those are alternate interior angles. Alternate interior. Therefore, JK is parallel to AC. So this side parallel to this side, and this side parallel to that side. Do we meet the conditions of a parallelogram? We certainly do. So we could say Jack is a parallelogram. You're going to want to write that down here because of the definition of parallelogram. And again, if I go back through those hints, right, I'm trying to figure out what do I need to prove? Prove that it's a parallelogram, meaning what definition do I have to meet? What conditions? Two parallel sides, and then working through what they give me. Last one. All right, here we go. Circle K intersects circle T at these 2 points, I and E. So they intersect them. So that's the given. We need to prove that KETI is a kite. We need to prove that it's a kite. Well, a kite, if you remember, a kite needs two distinct sets. Two distinct sets of congruent, sorry, it's a really bad congruent sign, congruent sides. So I need to show somehow that this side is congruent to that side and this side is congruent to that side. I need to show that somehow. So if I pull off the smaller circle, and we just draw it like this, here's K in the middle, here's I over here, and here's E. How do I know that KE is the same distance as KI? We got to go back to one of our earlier definitions of a circle. Segment KI congruent to segment KE. Definition of a circle. All right, if we were to pull the large circle off, the larger circle, and put it out here, we have T in the middle going to E. So there's E. And then we have I over here going to I. How do we know those two segments are also congruent to each other? So we can say IT is congruent to TE. Same reason, definition of a circle. It's just two different circles, which means KETI is a kite. Put that there because two distinct sides. We showed each sides are parallel because of the definition of a kite. So hopefully you were able to kind of walk through those with me and see how I'm using previous definitions, how I'm using our current definitions, and some of those hints to see what I should use. You've got two of them to practice today. Really try hard and see if you can't get through those two. If you have questions, please make sure that you reach out. Otherwise, until next time, folks, stay safe.